Assalamualaikum and very good morning. So today I will talk about how to solving water tank problem using ODE. So let's start. Um, okay, so what's the problem? So here is the problem. So I will explain it in a simple way. So imagine you have a tank and then there is a leak. So we want to find the time when the tank is empty and also the temperature of the tank when the tank is empty. So this is our objective. As I mentioned earlier, the time when the liquid finish and also the temperature of the liquid just before it's fully drained. So here is our solution. First thing first, we determine the parameters and also the initial conditions. Here is given conditions. So for the ODE, we use two terms, which is Torricelli's law and also Newton's law of cooling. So this is our first ODE and this is our second ODE. So let's start to calculate time when tank empties. So basically this is Torricelli's law, but you just arrange it so it becomes dH and dt here, and then you integrate both sides, and then to find initial condition, you set the h not equal to 0 and then t is also equal to 0, so the c you got set h naught, so the equation will be ht and this. So after you get the equation of h, which is height, you can substitute all parameters that given in this slide here to our formula. So here we substitute the a and g, and also we get this, and thus we substitute in this formula, then we just get this equation. After get this equation, we want to find the when tank empties, what is the time. So we just set it to 0, which is the height equal to 0, so that we can find the time in final. So the time is 6.39 seconds when the tank is empty. So moving on to the next is calculating the temperature when tank empties. So here is Newton's law of cooling. We are using integrating factor here, multiplied by general solution, and then we just integrate both sides of this equation, and then for this equation also you use your integrating factor and then you substitute it in this integration here, right here. Okay, after that you got this equation. Seems complicated, so we will use substitution form, which is u equal to integrate of pt dt. So when you solve this, you get du over dt is equal to pt, and then this one you substitute into this long term, it will become this short. Okay, and then just cancel out each other, then you got this eu plus c, and then you substitute all of that things in this new equation to get this thing. Okay, so next part is finding the initial condition. So when the initial condition, we just set the time equal to 0 because it is in initial condition. So the equation we get is c equal to t naught minus t cool. So so we got c here, and then we substitute it into this equation right here. Okay, so you got this equation, exponent power of this. So after that, you just need to substitute ht into pt, which is the time here. You just substitute it in this formula. HCA called the density, the area, the capacity heat, and also this HT. So we substitute all the information here, and then you you substitute the final expression for temperature in this formula. You should get time, you should get 6.39 seconds, same as earlier, this one. And since we have to only calculate the temperature, and then we can just calculate temperature based on this time, you substitute in this T, you got 20 degrees C for the final temperature when the tank empties. So my conclusion is, uh, in this project we studied how water leaks from a tank using temperature change of over of water over time using 2ODs. So we have used ODE to model a soft dynamic reactor system, and also this approach is powerful because it helps us predict behavior over time in real world chemical problem systems. By combining these two equations, we were able to determine how the water level and its temperature change together. So I think that's all from me. Thank you.